Hello my dear student, hope you are fine and taking care of yourself at your home and doing practice for all the ray diagrams properly. Today we will discuss about the sign convention rules for the spherical lenses. Previous class I have explained about the ray diagrams formed by concave lens and convex lens. Today we will do the rule. Before starting the topic, please do like and subscribe my channel and press the bell icon button for further notification. So let's start the rule. So let's draw a lens. You can draw any lens. I am drawing convex lens. You can draw any lens. So it is a convex lens. So what is the first sign convention rule? Object is always placed towards the left of the lens. Object is always placed towards the left of the lens. All the distances are measured from the optical center. Now this is the incident ray direction. What is this? This is incident ray. The distances which are in the direction of incident ray are taken to be positive, and the distances which are opposite to the direction of incident ray are taken to be negative. Means the distances which are in the same direction of incident ray are taken to be positive, and which are opposite to this incident ray are taken as negative. So what you can simply say that which are towards the left of the optical center are negative, and the distances which are towards the right of the optical center are positive. And the distances which are above the principal axis perpendicular to it are positive, and the distances like A dash, B dash which are below the perpendicular axis, they are taken as to be negative. This is negative and these are taken to be positive. Clear? So you have to apply these rules in the numerical. So where we have to apply this? In lens formula. What is lens formula now? Lens formula gives a relation between 1 by V minus 1 by U is 1 by F. V is the image distance, U is the object distance, and F is the focal length of the lens. From optical center we measure the distances. From optical center to the object, it is an object distance, and V is the image distance and F is the focal length of the lens. This is your lens formula. In mirror we have done plus here. Here comes minus in lens formula. Next is magnification. Magnification for a lens, same, it is the ratio of the, denoted by M, it is the ratio of the height of image to the height of object, or you can write it height of image to the height of object in terms of perpendicular distance, like this. This is above the axis and this is below the axis. So this is height of object and this is height of image. So magnification can come positive or can come negative. In terms of horizontal distance, like x-axis distance, V and U. So it is given by V by U formula. It is also the ratio of image distance to the object distance. There is no minus in this. After this we will put sign convention. Now what we can relate it from these two? Height of image upon height of object is also is equal to V by U, and that is equal to magnification. This relation is used when these quantities are given in the numerical. After putting sign convention we can find magnification. If magnification comes positive, so images are virtual and erect. And if M value comes negative after solving, then images are real and inverted. So this magnification tells us about the nature of the image also. And moreover, if M value is greater than 1, so image is enlarged, magnification value M come less than 1. So you can from here relation comes to know that image is diminished, because this quantity Hi upon Ho becomes less than 1. So height of image becomes less than height of object. So that means it is a diminished image. Similarly, if it is equal to 1, so height of image becomes height of object. So same size image is there. So convex lens forms real, inverted and same size image. So after this all, there is next topic, that is power of lens. So let's do that power of lens. What is power of lens? Power tells us about the degree of convergence and divergence of a lens. With what angle? The power of lens. With what angle the rays will get bent. Power of lens is defined as the reciprocal of the focal length of a lens in meter. What is power of lens? Power of lens is the reciprocal of the focal length of the lens in meter. And if it is in centimeter, so we write 100 upon F in centimeter. Means if you will convert this F into meter, so you will divide by 100. So that goes in the numerator. So you just keep in your mind when F is given in centimeter, so you just put 100 here. Now what is the SI unit of power? That is diopter. Diopter is the SI unit of power of lens. What is one diopter now? 1 diopter is 1 upon 1 meter. That is 1 meter inverse. So what we can say that 1 diopter is the power of lens whose focal length is 1 meter. Now see these two diagrams. One for convex lens, this is optical center, parallel rays are there. After refraction they will converge to focus. And similarly here, this is concave lens, parallel rays are there. After refraction they will diverge out and appear to diverge from the focus on the same side. So what you have observed, this lies on the positive quadrant, means right side, and this focus lies on negative side. So this focal length is negative and this focal length is positive. This is positive, so this is negative. So when you will put here, power is 1 upon f becomes positive. So power is positive for convex lens and power is negative for concave lens. Clear? Like if I will say power is plus 2.5 diopter. So I am talking about which lens? I am talking about convex lens because it is positive. So it is the convex lens, and if I will write power is minus 2.5 diopter, so I am talking about which lens? You will say power is negative, so it is a concave lens. Now to get a sharp magnified image or clear image, combination of lenses is also done. Combination is done. So how to do that combination? So simply we will do the arithmetic sum of individual power of the lenses. So that P is calculated by P1 plus P2 plus P3 and so on. Like if I am having a power of plus 2 diopter and one I am having of power plus only of 0.5 diopter. So what is the total power becomes? 2.5 diopter with plus sign. So when we want to get a sharp image or clear image, opticians in many instruments, we have to combine also. So that is an arithmetic sum of individual powers. So you have to do practice for all these today. Next class we will do numericals related to these topics only. Thank you and have a nice day.